Hello, this is Jennifer Martinez. In this video, we're going to look at the sum and difference identities for cosine, sine, and tangent. And here they are. Notice how the cosine of A minus B is not the cosine of A minus the cosine of B. It's a little more difficult than that. The cosine of A minus B turns out to be cosine of A times cosine of B plus sine of A times sine of B. And we're going to prove that. So let's first do that. To derive a formula for the cosine of A minus B, we're going to start by looking at angles A and B in standard position on a unit circle where B is less than A. So there's a picture here. I will redraw it over here. So let's call this B. So this would be called the point Q. It says let S and Q be the points where the terminal sides of A and B respectively intersect the circle. So you can see this would be, this point right here would be cosine of B and sine of B on that unit circle right there, if this is 1. And A would be a similar thing. So A goes from here to here. And they call that S, and again that's cosine of A, comma sine of A. Again, when this distance is 1, makes sense because X is the cosine of the angle, that's A, and Y is the sine on a unit circle. So this explains the pink on the unit circle on the left. Now we're going to explain the blue. We're going to do that by reading on. It says, let P be the point 1, 0, and locate the point R on the unit circle so that the angle P0R or POR, which is the origin, equals the difference A minus B. A minus B is just this angle right here, A minus B. So if I have a point on the origin, here's my 1, 0, and I want that same distance as the pink, that's where I'm going to get the R from. And that would be the angle A minus B, and so they show it there in blue, right there. And we know that the X distance for that, since the angle is A minus B, is the cosine of A minus B, comma sine of A minus B. So let's show that. So here's the point 1, 0 on my unit circle, and this looks like it's the point R, which would be the angle A minus B, the same angles we have up there, just shifted, right? And it is angle A minus B because here's the A, and then we subtract the B. And this point right here, we'll call it R, is cosine of A minus B, comma sine of A minus B, since that's the angle. So you can see that these two distances are the same. So we're going to say that PR is the same as SQ. The blue line, which is here, this line right here, that is PR, is the same as the pink line here, the S and the Q. So what I'm going to do is use my distance formula that we learned in chapter 1. Distance between 2 points, x1, y1, and x2, y2. So let's start with PR. Let's find the distance of PR. I'm going to call this distance my x1, y1, and I'm going to call this my x2, y2. And so using this formula, I would get x2, which is cosine of A minus B, minus x1, which is 1 squared, plus y2, which is sine of a minus b, minus 0 squared. Let me extend that. And moving that down to give me more room, I'm going to now find the formula for SQ. So again, I'm going to call this x2, y2, and this x1, y1, and do the same thing. We're going to find the square root of x2, which is cosine of A, minus x1, which is cosine of B, squared, plus the same thing y2, which we know is sine of A, minus y1, which is sine of B. Extend that a little farther and square it. And believe it or not, when I simplify this, I'm going to end up with a formula. So let's go ahead and simplify this. First, I'm going to square both sides. When you square both sides, you end up with just the inside, but with no radicals. Now I'm going to FOIL everything out. Foiling this, I'm going to end up with cosine squared of A minus B minus cosine of A minus B, another cosine of A minus B, so it makes it 2 of those, plus 1. This one is just minus 0, so I can just call that sine squared of A minus B. The right side. Foiling the right side, we get cosine squared of A, and then we get minus a cosine of A times cosine of B. You get 2 of those, plus cosine squared of B. I'm officially running out of room. So let's move to the right just for a moment. Foiling the sine out, I'm going to get sine squared of A minus 2 sine of A sine of B plus sine squared of B. Okay, making this a little smaller so we can see the whole thing, you can see things are going to cancel. First of all, we know sine squared plus cosine squared is 1. So you can see that we have sine squared of A minus B here plus cosine squared of A minus B. Those two things make 1. I'm just going to rewrite cosine of A minus B, and we have plus another 1. So these two things make that 1, and what's left is minus 2 cosine of A minus B plus 1. So that's the left side. The right side, let's do the same thing. Cosine squared of A plus sine squared of the same angle, A, better be 1. One more. Go for a different color. We have here cosine squared of B plus sine squared of B is another 1. So those all go away. What's left here is minus 2 cosine of A, cosine of B, minus 2 sine of A, sine of B. We're almost there because we have 2 on this side and 2 on that side that cancels. So you can subtract minus 2 from both sides, and what you end up with is minus 2 cosine of A minus B on the left, minus 2 cosine A cosine B, minus 2 sine A sine B on the right. I can divide everything by negative 2, and we're going to get the formula. We're going to have cosine of A minus B on the left. On the right, we're going to have cosine of A, cosine of B, minus, plus, 2 negatives make a plus, sine A, sine B. Let me make that plus a little bit nicer. And that is the formula. And you can see that this is the same formula as what's written on our first line of our formula list. To get cosine of A plus B, that's the most difficult one. The rest of them are not so bad, because what I'm going to do is I'm going to let B, the second angle, be negative B. If I rewrite this as cosine of A minus a negative B, and I use Now the formula above, this would be equal to cosine of A cosine of negative B plus sine of A sine of negative B. And from the last section, we saw that the even and odd formulas for cosine and sine, we know that cosine of negative B is equal to just cosine. It's an even function, so it does not change signs, whereas sine of negative B is negative sine of B, so that changes the sign there. Sine is going to be a minus instead of a plus, and you will have, let's write this cosine of A plus B here, your second formula. The next one is sine of A plus B. Let's go ahead and figure that out. What we're going to do with sine of A plus B is we're going to use our cofunctions. Cosine of 90 minus, we know that sine of any angle is cosine of 90 minus that angle. So now using the distributive property, I'm just going to bring in that negative. And now I'm going to look at this in a different way. I'm going to look at it as cosine of 90 minus A. That's going to be my first angle. Then minus B. The reason I'm going to do this is I'm going to end up with something different. So now I'm going to use cosine of the difference of two angles. I'm going to use this formula up here. And what I'm going to get is cosine of that first angle, 90 minus A, times cosine of the second angle. And then we have a plus. We get sine of that first angle times sine of the second. And we know that cosine of 90 minus A, that's a cofunction, that we know is just sine of A. We still have cosine of B. And the same with sine of 90 minus A, we know that that is cosine. And we have it. Let me write this as sine of A plus B. And there is the formula. Let's go up and look. That is the sine of A plus B. To get the next one, sine of A minus B, I'm going to use the same trick we did finding cosine of A plus B. So I'm going to take sine of A minus B, and I'm going to rewrite this as sine of A plus negative B. Okay, so I did that, we know the formula. We can use the formula above. This would be sine of the first one, cosine of the second, plus cosine of the first times sine of the second. And we know that cosine is even, so it stays the same. It stays cosine. We know sine is odd, so it changes sign there. So there it is. Let's check that out. Finally, working on the tangent of A plus B and A minus B. Let's start with tangent of A plus B. We know tangent of A plus B is sine over cosine of A plus B. And I'm going to rewrite the first one. I'm going to rewrite sine as sine of A, cosine of B, plus cosine of A, sine of B. And doing the same thing to the bottom for cosine of A plus B, we would have the following quotient. Now I'm going to do a trick. I'm going to multiply top and bottom by 1 over cosine of A times cosine of B. And it's going to put everything into tangents. So we're going to distribute that through, and we're going to end up with this last line here, a double fraction. Looks complicated, but if you notice, things cancel. The cosine of B's cancel. So you end up with just tangent of A. Cosines of A's cancel, so you end up with tangent of B. And then everything cancels here, so it's a 1. Nothing cancels on that last term, so it's just tangent of A times tangent of B. And I'll let you do the last one on your own. just going to use the fact that tangent of negative b is odd.